So you've registered for a chemistry class, and the first question you might have is, what is chemistry? So I've got my own definition. There's lots of definitions out there, but my definition is chemistry is the study of the property of matter and the actions of electrons. So a chemist would study, say, what the density of steel is and what its tensile strength is and how much weight it can handle, what its load is for a particular size and whatnot. But besides just studying how objects are in the natural world, we also study chemical reactions, and those chemical reactions are all about electrons. So an atom is a proton, a neutron, and an electron, and the protons determine which atom you have, but then don't really do anything. It's the electrons that do everything. Every single time you see a chemical reaction happens inside of you. Electrons are doing something. An easy example is fire. When you're burning a piece of wood, electrons from carbon are being given to the electrons from oxygen. That's why you need oxygen to cause a fire. You need something to take electrons and you need something to give electrons. And that's why when it's finished, when the fire is finished, the end product for carbon is carbon dioxide. And carbon dioxide, it doesn't have any more electrons to give. So we talk about actions of electrons. They get transferred, they get shared, something happens with them, and that's a chemical reaction. Almost everything around us, with the exception of some basic physics stuff like falling, is some sort of chemical reaction. Why we're studying this stuff is because we would really like to know what's going on in the world around us. And just in general, the only things that happen that aren't chemical reactions are nuclear reactions. So a nuclear reaction is, I had said earlier that nothing happens with the protons. During a nuclear reaction, something happens. If you were to take all three of these classes, in the third class, we would talk about nuclear reactions, but we're not going to in this one. So nuclear reactions are strictly not a chemistry thing. You could say it's nuclear chemistry or nuclear physics. But as soon as you throw the word nuclear in there, then we stop talking about electrons and we start talking about protons. That's the difference. And the difference between how the electrons behave and how the protons behave is the same as the difference between a stick of dynamite and a nuclear bomb. They're not in the same category. They're not on the same plateau as each other. One is much more powerful than the other and much more common than the other. So why are we here? Like why study chemistry or why study anything in the first place? So the reason that you should understand chemistry is, especially now, there's a lot of stuff happening in the world that chemistry has a hand in. I mean, we got out of the pandemic because a bunch of chemists figured out how to make a vaccine for it in less than a year. That's literally amazing. When they were trying to come up with a vaccine for polio, it was a couple of decades before Joseph Salk figured out what he needed to do for that. So the speed at which we're learning stuff about chemistry is much more rapid than it has been in the past, because we know a lot more and we keep building on what we know. There's a reason we would want to know as regular people about chemistry, because a lot of things happen in government which dictate what happens to our lives. So there have been a lot of news articles around chemicals called forever chemicals. And these are the things basically that Teflon is. So if we want to think about a forever chemical, I'd like you to just go ahead and think about Teflon. So it's on a pan, a nonstick pan, but it doesn't stay nonstick forever. We've all had to replace those Teflon pans. So where does that nonstick stuff go? It ends up in the environment. And what happens to it? Pretty much nothing. The reason it was nonstick is because nothing liked to attach to it, nothing liked to react with it. So what you end up having is all of this nonstick stuff just end up in the environment, and the environment can't deal with it. And then we start eating it and drinking it, and bad things happen with endocrine systems, and we have diseases that are caused by this. So if you understand why a particular chemical is doing something bad, then you can understand what you need to do with voting. And so the whole real reason we're here is Benjamin Franklin required all people in the United States to go to school until they were 7th grade. And seventh grade was the key because newspapers are written at a seventh grade reading level. And what is it that Benjamin Franklin's trying to do? He's trying to get you to read. So then you can read the paper and read about people who are running for political offices and what they stand for, and then be able to vote. So the idea that school is a thing is because of voting. School before was only for rich people. And as soon as we became a country, we needed everybody to go to school because we were the first democracy, true democracy. And so anybody could vote. Well, obviously there's issues with what I just said, but more people could vote, more people than just rich landowners. So we are here to learn stuff so we can move on to whatever our personal goals are. But a greater goal is a societal goal of understanding what chemistry is about, and then being able to pick people that you would like to be your representatives in government. All right, that's it.